I am an Rashid, faculty department of physics, previously the College of Arts and Science. Today I am going to discuss a very important concept, basic concept, that is dual nature of light. The title of the concept is dual nature of light. So before going to explain the character of the light, first let me explain what is light. What is light? You know that light is a form of an energy. Light is a form of energy traveling through space with enormous velocity. You know the velocity of light is 3 to 10.8 meters per second. It is also known as the speed of light. And the light do not require any medium for its propagation. Even in vacuum and also medium, travel with a velocity 3 to 10.8, 3 lakhs kilometers per second. This light exhibits dual character in nature, which is very important because nowadays in our daily life and experience, number of applications, reflection, diffraction, polarization, and also Albert Einstein also won Nobel Prize for his photoelectric effect. It is an experimental confirmation of particle nature of light. So the light exhibits dual character. Number of experiments reveals that light exhibits dual character in nature. They exhibit wave-like behavior and also particle-like behavior. So in absence of wave-like behavior, the light exhibits particle-like behavior. In absence of particle nature, the light exhibits wave behavior. Now see, light. So generally the light consists photon. The responsible carrier of light is a photon. Group of photons called light. Okay. So light is simply defined as consists group of photons. Photon is a massless particle. Photon is a massless particle. Travel to space 3 to 10.8 meters per second, and it is massless. This photon is exhibiting dual character. So wave-like behavior. And also particle-like behavior. Wave-like behavior and particle-like behavior. So light exhibiting wave-like behavior. Okay. So you know the phenomena like reflection mechanism, refraction, very important concept, interference. So we have in surface interference of light, diffraction of light, polarization of light. These are all conforms the wave character of the light. This all conforms the wave character of the light. So light exhibiting wave, the reflection, refraction, interference, diffraction, polarization. So now suppose we have interference concept, diffraction of light, and also polarization of light. Okay, the first unit of wave optics is interference of light. So what is interference? What are the characteristics of interference? Important. Okay, types of interference. I mean the division of amplitude, division of wavelength, and also the intensity distribution. What is the intensity of the interference distribution diagram? Because usually we can observe, in electronics experiment, alternative dark and bright fringes appears when a monochromatic source incident in a convex lens. This is an experimental fact. What is the reason for the maximum intensity and minimum intensity? We call it as bright and dark fringes. And also we have seen that the reason for the color synthetic fluids. Color synthetic fluids is purely due to interference of light. When a light incidentally on the surface of the glass or any soap bubble, so simply the light is reflect, one part of the light is reflect and one part of the light is refracted. So due to the angle of incidence, if you change the angle of incidence, colors also changes. Okay now. So what is the reason of colors formation influence? Similarly, Newton's experiment. It is a direct application of interference. Due to interference pattern, in the nodal rings we can observe alternate dark and bright fringes. And biplexal experiment, even in biplexal experiment, biplexal interferometer also, you can observe alternate dark and bright fringes. It is purely interference pattern. The interference pattern is based on the superposition principle. Here, the light is divided into two wavefronts, get superimposed in space at a time t. So they form a alternate dark and bright fringes. In some points, the intensities cancel each other. In some points, the intensity is additive. Due to this reason, we can observe alternate dark and bright fringes. And also, the second unit of the wave of this is diffraction of light. Diffraction of light. What is diffraction of light? The bending of light around the edges of an obstacle is known as diffraction of light. What is diffraction? You know what is Fresnel's diffraction? What is Fraunhofer diffraction? The importance of diffraction, applications of diffraction, the intense distribution of diffraction pattern. So, the interference pattern, the intensity of the all bright fringes is equal, whereas we are going to observe diffraction pattern, the intensity of the peaks not equal. Okay, so we can observe maximum bright fringe, which is known as the principal maxima. Then after first principal maxima, the intensity of first principal maxima decreases, second principal maxima. And also we are going to see the diffraction will be a single slit, diffraction will be a number of slits. And also resolving, you can find the resolving power of weighting. Resolving power of weighting. So this is the content of the second unit of studies. The third one is polarization of light. Here also we can confirm the wave property. So on the one sidedness of light is known as the polarization of light. There are three different types: plane polarized light, elliptically polarized light, and circularly polarized light. What is plane polarized light? What is circularly polarized light? What is elliptically polarized light? And also polarization can be observed in three different methods: refraction, reflection, and also double refraction. Then what is Nichols prism? What is Nichols prism? And what is meant by Lorentz offset polarimeter? And applications of, we are going to see applications of polarization. So these four, reflection, refraction, interference, diffraction, polarization, directly confirms wave character of the light. This is another side. Also exhibit, the light is also exhibit particle-like behavior, but the simultaneous determination of the wave and the particle is not possible. Light exhibit wave in absence of particle nature, exhibit particle nature in absence of wave behavior. So the particle-like behavior is confirmed by photoelectric effect. One of the remarkable experiment which is discovered by Albert Einstein. This is an experimental confirmation of particle nature of the light. What is photoelectric effect? When the light incidentally on a metal, if you provide sufficient energy to the electrons which are inside in the metal, after gaining energy, electrons are ejected from the metal. This is known as a photoelectric effect. In simple words, the ejection of electrons from metal is known as photoelectric effect. So Albert Einstein one known for this photoelectric effect. And also the confirmation of the particle nature provided by quantum effect also. Quantum effect, which is almost similar to photoelectric effect, but a little bit different. So quantum also performed one experiment to confirm the particle nature of the light. And also you can see the transition between the energy levels. You know, atom is visualized as a different energy levels from ground state to first exit, second exit, and different states. So this is the transition between energy levels also confirms the particle nature of the light. Okay. So however, the light group of photons is called light. Travel through space with 3 to 10 meter per second. Exhibit dual character. One is wave-like behavior, the other one is particle-like behavior. So therefore, the wave-like behavior is confirmed by these concepts, and the particle-like behavior is confirmed by these concepts. But according to de Broglie hypothesis, this is about light, and also you know light is available in 7 portions in the electromagnetic spectrum. The same light is available 7 portions, which is symbolically represented by wave. The photon is symbolically represented by wave. So this light is, which is also known as electromagnetic radiation, electric and magnetic pulse. Light is also known as electromagnetic radiation, consists electric magnetic pulse. Okay. If you represent schematically diagrammatically electromagnetic pulse, x, y, z. If x represents the direction of the propagation of the wave, and y represents the magnetic pulse, z represents the electric pulse, which are all perpendicular to each other. If this is the direction of the propagation of wave, direction of propagation of wave, direction of the propagation, the y-axis represents the magnetic pulse. Magnetic pulse vibrates perpendicular to the direction of the propagation. Where the z-axis, this is the z representation, where z-axis represents the electric component, y-axis represents the magnetic component, and the z-axis represents the electric component. So electric and magnetic pulses vibrates perpendicular to each other. This is the diagrammatic representation of the wave. This is the representation of the electromagnetic radiation or light. Okay. Now this light is available in 7 portions. 1, 2, 3, 4, 5, 6, 7. Available in 7 portions in the electromagnetic spectrum. What is mean by electromagnetic spectrum? What is mean by electromagnetic spectrum? The entire region over which the entire spectrum can exist is known as an electromagnetic spectrum. Okay. So if you see from bottom to top, this light, electromagnetic pulse or photon, available in radio. If you see the wavelength side from bottom to top, radio waves available as a radio wave. The second portion from bottom to top is microwave. The same light is available in microwave wave. The wavelength of the microwave wave is lesser than the wavelength of the radio wave. So the wavelength is decreases. So lambda is this is the decreases. The wavelength is decreases. Okay, the wavelength. So wavelength decreases in the frequency. Wavelength decreases in the frequencies. This is the direct relation, inversely proportional. So this is the second from bottom to top, second region of the electromagnetic spectrum. This is known as electromagnetic spectrum. The third region of electromagnetic spectrum is infrared. Further, infrared is divided into 3 portions. 3 portions. Now, from bottom to top, far infrared, very near infrared, very near infrared. Far infrared, near infrared, very near infrared. Further, the infrared waves are divided into far IR, near IR, very near. And the fourth from bottom to top, which is very very important, you and I are able to see everything, images, objects, known as visible portion, visible region of electromagnetic spectrum. This is most important. Okay, now, so below this visible portion and above this visible portion, okay, there are 3 infrared, microwave, radio, and remaining are UV, X-ray, and gamma ray portions. Okay. Now further, the visible region is divided into VGR, VBG by R. So the wavelength of red of the red is greater than the remaining one. The wavelength of the violet is less than the wavelength of the red. From bottom to top, red, orange, yellow, green, blue, indigo, and violet. So visible portion of electromagnetic spectrum have 7 regions. 7 portions R, O, Y, G, B, and V. As wavelength increases with GR. The fourth portion of the electromagnetic spectrum is ultraviolet. Ultraviolet is an electromagnetic spectrum. Okay. The next one is X-ray region, and the last one is gamma ray region. You know the wavelength of the from bottom to top, the wavelength of the regions increases. Okay. So the wavelength of the radial is much greater than the X-ray and gamma ray regions. X-ray gamma ray region. X-ray and gamma ray region. So therefore, this is about light is dual character nature. But according to de Broglie hypothesis, this duality is not only confined to light, not restricted. So according to de Broglie, must be a universal concept. The duality is not only restricted to light, it must be universal concept. So according to him, the material particles also exhibit dual character in nature. You know, the matter is made up of molecule. Matter is made up of molecules. For better understanding, this is the division. Molecules are made up of atoms. The atom is made up of consists generally electrons and nucleus. Further, the nucleus is divided into protons and neutrons. So ultimately, the matter consists electron, proton, neutron. So this electron, proton, neutron are called material particles. So according to de Broglie hypothesis, not only light but also the material particles, electron, proton, neutrons do exhibit dual character in nature. So the material particles are associated with wave in motion is known as de Broglie waves or matter waves. So the duality must be a universal concept. The duality must be a universal concept according to de Broglie. So it derived a famous relation which is known as wavelength of the de Broglie or de Broglie wavelength, which is mathematically expressed by lambda is equal to h. So based on this concept, we are going to explain, we are going to study the wave property of light and also the particle nature of the light. But that is interference, diffraction, polarization, total. Okay, now, thank you.